Hello everyone, welcome back to my channel. Street Tips here. What I have here is a sample of 14 karat gold that a manufacturing jeweler was using to make a custom made piece of jewelry for a customer. And when they cast it into this shape and then he tried to roll it out, if you look on there, you'll see there's some pitting in the metal. It wouldn't roll out real smooth. Plus, it was cracking a few places along the edges of the metal. And this is a telltale sign that some lead got in this alloy. Lead, even in just small trace amounts. For example, if someone repaired a piece of jewelry in the carat scrap that he used to make this bar. If someone repaired a piece of jewelry in there with soft solder that contains lead and tin, that's all it takes to ruin the ductility and malleability of this entire piece of gold. So what we're going to do, we're going to take this, and he's got a few little scraps here from the pour that he did, and we're going to refine this into pure gold. And then we're going to take the pure gold that we get and alloy it with some other metals to produce some 14 karat gold in this video. Here we go. All right, I just want to take a close look at this piece of metal. He's tried to shave it off with a tool there. You can see there's tool marks in there. But if you look, like right up in here, you'll see some pitting in the metal. Over here, there's some pitting. And what he did is he tried to, there's a whole bunch of it on this side. He tried to cast this piece like this, and it had pitting in it. So he remelted and recast it, and it just keeps coming up the same with all that pitting in there. I don't see any cracks along the edges. He was talking about it was cracking as he rolled it out. But this is a telltale sign that we've got a little bit of lead in here. And so we're going to refine this metal and then realloy it with fresh pure silver, pure zinc, and pure copper. I'm going to take the pure gold and alloy it with those other three metals and make some plumb 14K gold. I'm going to start out by testing this piece of metal that I got from that jeweler with some acids here. I've got some test needles. I'm going to put the 14 or the 10K test needle there on the to the right, 14K test needle to the left, and then we're going to put a drop of acid on here, 14K gold test acid, and we're going to see how these scratch marks react to this acid. This will tell us what the carat of this gold is. All right, it's been on there about 30 seconds, and you can see this is the 10K scratch over here on the right. This is the 14K scratch over here on the left. This is the unknown sample in the middle. These two look similar. This one doesn't look anything like the 10K scratch. So we verified that we have, in fact, 14 karat gold in this sample right here. Let's check the weight on the material we have here. I'm just gonna look at that, man, how it cracks when I bend it. See that? That is an indication that we've got some contamination with lead in here or something. But I'm gonna roll this up just to make it easier to work with in the crucible. And we're going to put it up here on the scale. I'm going to add these other few pieces that he had. This is from the casting. It's the same metal. And we've got 52.3 grams of 14K. If you remember from my previous video, we're going to use this constant right up here, 1.265, to calculate how much silver we need to add to this gold here. So we have 52.3 grams. We're going to multiply that times 1.265, 52.3 times 1.265 equals, so we need 66 grams of sterling silver. We need 66 grams to properly unquart this 14K. Got a piece of sterling here. You can tell it's sterling because it's written right on the back of the piece. And we're going to throw this on the scale. I've already pre-measured this. We got 66.3. We need 66. That'll be fine. I'm going to put our metal in this crucible. And what we'll do is we'll take it out here to the melt table now and get it alloyed so that we can begin the hot dilute nitric acid treatments. All right, now we're going to pour off the tap water and capture the gold in a beaker here. And now we'll rinse the imported gold here with plenty of distilled water to get all the chlorinated tap water off of it. Chlorine in the tap water will react with the silver nitrate and form silver chloride, which could cause problems for us later in the process. We want to avoid that. All right, here's our unquarted gold. There was a little bit of borax in there that came over with the pour, but that's quite all right. That won't hurt nothing. It will dissolve in the nitric and leave our reaction. So I'm going to cover this with about 100 milliliters of distilled water. I'm going to put in some nitric acid, 68% concentrated nitric acid, 68 to 70% assay. And we're going to start pulling the base metals and the silver that we added out of this gold. Put it up on some heat and just let this react. This reaction back here is complete. I can tell because the fumes have gone away. And so now what we're going to do is we're going to pour off this solution out of here into a silver container here. But before I do that, I'm going to burn some pieces of sterling silver and put them in this container. And what this will do for me is it'll consume any residual nitric acid that I'm about to pour off out of our imported gold reaction back there. So this silver is going in. All right, now I'm going to take and pour off this solution into my silver jar here. It's down the sides a little bit. Just pour this off now. This solution that I'm pouring off will contain silver from the imported gold. What we're doing is using hot dilute nitric acid here to dissolve out the silver and the base metals out of this gold, and it will leave behind nearly pure gold after these reactions are complete, because the nitric acid won't dissolve the gold. Stick it back up here on the heat. Add a little bit more water here. And then we're going to add some more nitric acid and continue the hot dilute nitric acid treatments on this imported gold. Our second nitric acid boil is complete. I can tell when the fume production falls way off like that. Fume production is real light in here, so what we'll do now is pour this off into our silver jar here. And then we're going to do another nitric acid boil on our imported gold. Again, that solution I'm pouring off will be full of silver, and as you can see, when it hits that sterling down in the silver jar there, there's a bunch of excess nitric in there as well. So now we'll add some distilled water to our imported gold. See how that's looking nice and brown, staying together? I'm going to add some more distilled water here. Put it back up on the heat. I'll add some more nitric acid. And we'll let this third nitric acid boil. All right, this is our third nitric boil. It's done. I'm gonna go ahead and pour this off into our silver jar here and do a fourth nitric acid boil. We're going to keep going until we get all of the silver and base metals dissolved out of this imported gold. We can tell when we've achieved that when these nitric acid boils remain clear and colorless. Add some distilled water here, about 100 milliliters or so. Put this back up on the heat now. Add some more nitric acid and do a fourth nitric acid boil. It's time to make some more stanz chloride Today is 24 October. I write that right on the bottle. Helps me keep track of when I prepared a new batch. I've got pure tin shot. I got this on eBay. It's about 10 bucks or something like that, maybe not even that. I'm gonna measure out a gram of that. And then we've got some stanz chloride crystals here. Got that on eBay as well. I bought this about 10 years ago. I was about that full. It's lasted me all this time. It's only, I don't know, it's a couple bucks on eBay. About a gram of that. And now we're gonna add this to our bottle. Carefully here. All right, now I'm going to put in 25 milliliters of distilled water. And then we're going to add 30 drops of hydrochloric acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. That's good enough. And then we're going to put the cap on it here. And we're going to shake it up. And it's ready for immediate use. All right, I've got some pieces of filter paper cut up here. I've got my standard gold testing solution. It's 1 gram per liter of gold dissolved in solution. And we're going to take some of our freshly prepared stanz chloride testing solution now. Test it. Make sure it's good before we start using it. There it is. This is our 7th nitric acid boil. I'm going to pull this down off the heat. If you look at the gold and the solution it's in right now, you'll see it has a slight yellow tint. Now, people say that nitric acid will not dissolve gold, but in my experience, I have seen it happen, and it looks like it's happened right here. It's a piece of filter paper on the end of a bamboo skewer. I'm going to get a little bit of it on the end of the paper there, and we're going to take some of our freshly prepared stanz chloride testing solution. We're going to test for the presence of gold in that boiling nitric acid. And there you see it. You see that purple stain? That is gold in solution from boiling nitric acid. All right, the only thing you can conclude here is boiling nitric acid will put gold in solution. Gold is slightly soluble in boiling nitric acid. Here's the proof. Our solution down here was colorless about an hour and a half ago. I intentionally left it on to boil a little longer than I normally would to prove a point here that boiling nitric acid will put gold in solution. Pour this off. I got a special container set up for nitric that has gold in it, and I can treat it differently than the nitric that has silver in it. There shouldn't be any silver in this nitric that I'm pouring off right here. All right, here's a look at the pure gold. Nice and brown, caramel colored down in there. What we're gonna do now is I'm gonna rinse it off real good and pour it into my silver jar. Get as much of the nitric as we can rinsed off of there. Any gold in solution that goes in my silver jar here will get cemented out with the silver, and then we'll add it to the silver cell. It'll get trapped in the silver cell slimes, and we'll recover it when we do the slimes. Alright, here's our imported gold. It's been parted with hot dilute nitric. It's been rinsed off with some distilled water. I'm going to add some hydrochloric acid here. That's about 150 milliliters of hydrochloric acid. Add a little bit of the seal from the hydrochloric acid went in there with it. Get that out of there. Come on out of there, please. Alright, let's put some sulfuric acid in here now. This is the important step. This is the purpose of this refining, is to get this lead out of there. I'm going to add about 1.5 milliliters here, just to make sure there's plenty of sulfuric acid in there. What'll happen is the sulfuric acid will combine with any lead that's in solution in here and form lead sulfate, and then we can filter out 100% of the lead out of our gold. Okay, I'm going to add some squirts of nitric acid now. It's about 3 milliliters. 6, 9, 12. Let's do it. That should do it for right now. Stir this up. Stick it up here on the heat now. Let this dissolve. That only took about 10 minutes, and every bit of the gold has gone into solution. I'm going to pull it down off the heat now, and I'm going to add some ice to cool it off, and then we'll precipitate it. Well, first we're going to filter it, and then we'll precipitate it with sodium metabisulfite. I've added a filter paper to a Buckner funnel here. And what we'll do, hook up the vacuum line. And the solution's cooled now. It's about the temperature of a glass of iced tea. I'm going to pour this right on in now and filter it out before we precipitate out the pure gold. And we don't have a bunch of solids in here. I've got another flask here. What we'll do is pour the solution right back through the same filter. See if we can get it to clear up a little bit. Let's precipitate some gold. Get this funnel out of the way here. Rinse that off. It's got a little gold on it. Get this out of the way. Just going to set this in the back here. We're going to transfer the filtered gold into this clean beaker now. And then we're going to add some sodium metabisulfite and drop the pure gold out of this solution. Here we go. Never get tired of watching this. That should do it. While I wait for this to settle, I'm going to go in and do some editing. Just wanted to show you all the junk that we got filtered out of our solution before we precipitated, the lead, if any, will be in that filter, will be filtered out now as lead sulfate 100% from our gold in this beaker. Here's an interesting view of the gold kind of hanging in the solution there. And what we're going to do next is I've got a filter set up here. We're going to filter the gold out of our solution. If this was my gold, what I would do was just rinse it, pour the rinses off into my temporary waste container. But this is not my gold. This is a customer's gold, so I'm going to filter it out in order to be able to capture 100% of it in this filter. All right, I got the liquid poured through the filter. There's a little bit of gold in that filter, you can see. Now what we'll do is add the rest of the gold from our beaker in here so we can give it a couple rinses with some hydrochloric acid. All right, let's get some hydrochloric acid in here and rinse some of these chemicals off while it's in the filter. All right, now we're going to rinse the gold with some distilled water. I've got the gold nice and rinsed out. So now what we're going to do is we're going to take it down out of this filter here, and we're going to put it in this crucible. Pull it out carefully. Just like that. And now we're going to transfer it over to our melt table over here. Going to do a quick melt and pour it into a bar. Okay, here we go. I'm going to add the gold bar back into the melt dish. That's starting to melt, so now we're going to add the piece of zinc in here. That's what I thought. That zinc acts very peculiar when you first put it in the melt dish. I'm going to put in our silver now. And then the copper. Got a brand new graphite stir rod here that I use to alloy everything. All right, here we go. Here's our bar of 14K gold. It's pretty ugly looking, which was expected because the metals that we alloy with the gold will oxidize, especially if they're hot. So what we'll have to do is buff this up now and get that oxidation off the surface. And here's our little bar of 14K gold. Here's our little bar of 14K gold. It's got some oxidation on the top there. We can buff that off. If you look underneath here, that's what it'll look like after we buff it. So let's look at the weight here. We were expecting a bar that was 50.2 grams. This bar is 49.0. So we lost 1.2 grams during the melt. Well, I gotta admit, this was a little bit of a strange video for me because normally I'm taking metals out of the gold, and in this video we alloyed metals in with the gold to produce a 14K gold alloy. I'm fairly certain that we've got all the lead out of here so that when the jeweler goes to roll this out, it should roll just like butter. All right, this will conclude the 14K gold alloy video. Thank you for watching.